chillers, evaporators, etc. So friends, in this session, we learned the application of the first law of thermodynamics to an open system. We have also studied various concepts such as mass balance for unsteady flow system, mass balance for steady flow system, flow work and flow energy, energy balance for steady flow open system. We also learned the applications of steady flow energy.
Now application of first law to the closed system.
Applications of first law of thermodynamics to a closed system. In this session, we will study the applications of first law of thermodynamics to a closed system. Here, we are going to see some processes. They are constant volume process, constant pressure process, constant temperature or isothermal process. Let us apply these processes to a closed system or non-flow processes. Let us begin with the constant volume process. Observe a piston cylinder consisting of an ideal gas of mass m. Let the pressure applied be P1 and temperature be T1. Volume occupied by this gas is V1. Now, if we apply heat to the gas, its temperature will increase, whereas the gas inside the cylinder will try to expand. Now, in order to apply the constant volume process, we have to increase the pressure on the gas by adding weights on the piston. Observe the PV diagram and let the final pressure, volume and temperature be P2, V2 and T2, where V1 and V2 are equal. We know that the work done by the system can be expressed as W equals integration P into dV. As volume is constant, dV will be 0. Therefore, W will be 0. In this process, the heat supplied can be expressed as Therefore, heat supplied for the process from state 1 to state 2 is given as By applying the first law of thermodynamics, we can find the specific heat supplied at constant volume. Observe that, however, from equation 2, Q equals to On deriving the given equation, finally we get the equation for specific heat, that is equation number 4. Now let us study the constant pressure process. Consider a piston cylinder having some amount of gas. The initial state of this system is P1, V1 and T1. Here, in this process, the pressure is kept constant and heat is applied. Final state of the system is P2, V2 and T2. Observe the PV diagram. It shows the pressure P1 and P2 are equal. So the work done can be expressed as heat supplied in this process can be given as Now, by applying the first law, where we have, after putting all the values in the above equation, we get this equation is known as Mayer's equation. Now, if we put W equals P2 V2 minus P1 V1 in the equation, on evaluation we get Q equal to H2 minus H1. Let us study the constant temperature or isothermal process. An ideal gas at constant temperature will follow Boyle's law, that is, P into V equals constant. Observe the PV diagram. Here, the ideal gas undergoes an isothermal process from state 1 to state 2. Let us see the expression for work done. On evaluating, finally, we get work W is equal to the change in internal energy can be expressed as, since this is a constant temperature process, therefore delta U or change in internal energy is 0. Therefore, heat transfer in this process can be expressed as Let us revise the topics covered in this session. We learned the applications of the first law of thermodynamics to a closed system in various processes such as constant volume process, constant pressure process, constant temperature or isothermal process.
So that is regarding application of first law to the open system and to the closed system. Now first law of thermodynamics. One experimental setup, how to conduct experiment for first law.
Iya, ayo ambil.
Oke ya, 1, 2, 3. Wih. Oke ya, bisa sama.
Oke, bagi ketat dulu.
Oke, 1, 2, 3. Tadi pergi ambil. Ambil yang atas.
Ambil tuh.
Bagus. Bagi lagi.
Oke.
So that is regarding the experimentation to prove the first law of thermodynamics. In this law, the gas or air which was inside the container, because of the heating of that air, the container burst. Now electrical work is done on the system by the generator, which is driven by the falling weight. This is the example of first law of thermodynamics. Here generator is there and electrical work is done over this generator. This is the electrical supply or battery, positive and negative, and with the help of this electrical energy, this rotor rotates and this object is lifted. Or in reverse, if we rotate this object if we move this object from up to down, this will rotate and here electricity will be generated. Both the sides it's possible. So electrical work done, here the work is done to produce the electricity, or we can use the electricity to produce the mechanical work. Now first law, application of first law, a gas confined in a cylinder with a movable piston. Here piston is movable, this is the cylinder and here gas is there. The force applied is equal to pressure into area, the pressure over here multiplied by the cross sectional area of the cylinder. What is the value of the internal energy for the gas in the cylinder, this gas, and how does the confined gas exchange energy with the surroundings, and how can we calculate the energy, that is heat and or work transferred, added or subtracted to the system. So for that, the state of the gas is described by the ideal gas. PV is equal to nRT, and first law can be applied to this system. Delta Q internal is equal to delta Q in plus W on, and this is the integration and equation to find out the change in energy. This is the quasi-static process, a type of process where the gas moves through a series of equilibrium states. Then we can apply the ideal gas law. Only to the quasi-static process we can apply the ideal gas law. In practice it's not possible, but by slow movement of the piston we can have the quasi-static process. So with this, let we conclude today's talk. Today we discussed about the zeroth law of thermodynamics, first law of thermodynamics, their applications and experimentation to prove both the laws. We will continue with some more theoretical aspects in the next time. Thanks to all of you.